Exercise 2.3, question 2. Check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first. So let's just take a simple example. Let me use numbers for this. Suppose I had written two numbers, 2 and 10. And then my question is, check whether the first number, that is, check whether 2 is a factor of the second number, which is 10. So check whether 2 is a factor of 10 by dividing the second number by the first one. So here, how do I know that 2 is a factor of 10? I check that when I divide 10 by 2, is it a complete division or not? And it really is complete division. That means my remainder comes out to be 0. So when is a number or a polynomial a factor of another? Well, it's a factor if upon division the remainder comes out to be 0. So that is precisely what we need to check here. These ones on the left we have to check them whether they are factors or not, and these ones on the right are the dividends. These are what you will check by dividing with the first one. So let me just start this with the first example here, first part here. Alright, here we go. Now I've set this up in a nice division situation, and you know how to divide now from the previous question. You will first of all divide the highest power term here in the dividend by the highest power term in the divisor. So this is going to be 2t squared. So the first one is going to be this exactly, because you multiply this term with every term of the divisor. The next one is going to be minus 6t squared, because 2 times 3 is 6. Now what you do is you change the signs here of each of the terms in the second line, and then you cancel out whatever you can, or you add them basically. Now you'll see that 2t to the power 4 and negative 2t to the power 4 of course will become a 0 together when you add. As for the others, this one is going to come down as it is, 3t cubed. This is minus 2 plus 6, so that will be plus 4t squared, and the others will come down as it is again. Next up is this, you divide the highest power term in the new dividend by the highest power term in the divisor. So 3t cubed divided by t squared is just 3t. Then you divide this with the other term as well, and you will get a minus 9t. Yet again, you know, you have to change the sign, and then that'll add these numbers. These two get cancelled out, these two get cancelled out. What you're left with is 4t squared minus 12. Finally, again 4t squared divided by t squared, this is just going to be 4, and you multiply this. 4 times minus 3 is minus 12. You change your signs, and this time you add. Everything vanishes, it's all gone, and so your remainder really is equal to 0. So this second polynomial is divisible by the first polynomial, or you can say that the first one is a factor of the second one. So yes, it is a factor here. As for parts 2 and 3 now, I'm not going to do the complete division because you've learned that in the previous question as well. I will just show you the division, and then we'll go over that and talk about the final conclusion. Alright, here is part 2. Before you just read the entire solution, try this yourself, pause the video, and once you play this, you will see the entire division here, of course. Okay, now if you've tried, you would see that the remainder in this case does not come out to be 0. It's minus 18x minus 6, and since the remainder is not equal to 0, the second polynomial is not divisible by the first, or first one is not a factor of the second, which is what you had to check. Finally, before I show you the solution with the part, this time I'm going to show you the next part on an empty screen. Alright, here you go. Here's part 3. Pause the video, try the division, and then when you play it, you'll see it out. Alright, I hope you tried. Here is part 3. So here when you see on division, the final remainder that we get is 2, and 2 of course is non-zero. So since the remainder is not 0, the second one is not a multiple of the first, or you can say that the first one is not a factor of the second, and we're done.